Now, the other way in which we can describe the mean of group data, so this should look familiar to you. In Unit 1 in Chapter 2, we looked at a frequency, a grouped frequency distribution, and so now we can actually find the mean of that. And unlike a traditional mean, it still is the average. However, in this particular table, I don't know any of the numbers. I only know that there's 11 values between 0.5 and 3.5. And there's 12 values between 3.5 and 6.5. I don't know what those 11 values are. So for us to find the average, we have to figure out a way or devise a way to estimate that what these 11 numbers could be and what these 12 numbers could be. And so in doing that, we look at our mean is going to be described for this type of distribution. It's still X bar because it's a sample mean. So a random sample of bonuses in millions of dollars paid by large companies to their executives is shown. So these boundaries represent bonuses in millions of dollars, and 11 people received a bonus from $500,000 to $3.5 million, all the way up to one person getting the bonus $12.5 million to $15 million. So for me to find the average of the distribution, I look at the sum of the frequency, so these numbers, multiplied by the midpoint. So the midpoint is something that we are familiar with as well from the previous unit. Right? The midpoint was described as the lower bound plus the upper bound divided by 2. So that's what we looked at. That is what we looked at the midpoint being. So we first want to find the midpoint, and the midpoint for us in this class is going to represent the typical value for those 11 values in that interval. Now, needless to say, we don't have the actual data, so we don't know, but we're using that to represent like the typical value. And subsequently, the midpoint would also be like an average of those two numbers, because we're adding them together and we're dividing by 2. So that for us, that's a typical value. So to find the midpoints, and again, this comes from section 2.1 and 2.2, I would add together the upper bound and the lower bound, divide by 2, and that's my midpoint. In this case, that midpoint is 2. So the typical value for these 11 numbers is estimated to be 2. And we do that for all of them until we get to the very end. And I'm just, quickly, I noticed that over here, each time they're adding by 3. So if I just added 3 to 2, I get 5. If I added 3 to 8, 3 to 5, I get 8. At 3 to 8, I get 11, and 3 to 11, I get 14. So we can do that as well. Now, this last column is what is going to help us find the average. So the average is the sum of this column, the frequency times the midpoint. So if we actually knew these 11 numbers, we would just add those 11 numbers together, and that would be the total bonus for the total bonus paid to the 11 people in this class boundary. But since we don't know the value of each 11, instead, we're going to use the midpoint to represent the typical bonus that each person received, each of the 11 people received. So the total bonus that we're estimating to be paid out for this interval will be $22. It's it represents the frequency of 11. So frequency of 11 times the midpoint of 2, and that gives us $22. Same thing with the next one. We look at taking a frequency of 12. So there's 12 individuals in this interval that received the bonus from $3.5 million and $6.5 million. And a midpoint of 5 just tells us that the typical bonus was around $5 million. So those 12 people, if we say received each $5 million, then that's $60 million total for that interval. And I'm just rewriting it so that the values line up. So 11 is the frequency, x of m is the midpoint, so 11 times 2 is 22. And then we complete that process for the rest of the information in the table, and we get values that represent the sum of the bonus for each class boundary. And then to find the mean of the entire distribution, the sample mean, I take the sum of this column, so 22 plus 60 plus 32 plus 22 plus 14. I want to add that together, So we add that together, we get 150. And then N represents the total. In this case, the total sample. The total sample would be, if I were to add all these together, how many people are represented in this distribution to have received a bonus, and it's 30 people total. So the sum of the frequency times the midpoint divided by N, 150 divided by 30, that would be 5, would be our average, $5 million. So the average bonus that was paid out was $5 million. Now the other thing it wants us to find is a modal class for the distribution. So in this case, just like the previous problem, we could find the mode for the previous problem because we could actually look to see which number was repeated. For this one, we don't have that luxury. I don't know the values, the 11 different numbers in this interval. I don't know the 11 different numbers in this class boundary. I don't know the 4. For all we know, these 4 could be the same number, and this is 11 different numbers, and this is 12 different numbers, and really the mode is here. But because we have a grouped frequency distribution, we consider a modal class represents the class, so one of these, that has the highest occurrence of values. So that would be 12 would be our modal class. And then we can even describe the shape of this distribution. If I make kind of a quick sketch of a histogram here, we can kind of describe the shape of the distribution. We really don't need to make a histogram, but I still like to make one just for a visual, for those of you who are very visual. And so based on the frequency and the class boundaries, this is the histogram, and we can see it's skewed right. The majority of the data is clustered on the lower end of the values, and then as it increases in value, it starts to taper down. So the mean, in this case, would be far greater than the median.